Number 2C. And question number 2, just in general, is focused a lot on the idea of do you understand this idea of positive velocities and positive positioning and positive acceleration versus the negative versions of that. And for part D, we'll look at that in a second, but we talk about the distance traveled, which is slightly different. Okay, so here it says acceleration, find the acceleration of particle Q at time equals 1, and is the speed of the particle Q increasing or decreasing at t equals 1? Well, first of all, we need to find the derivative. Okay, so we have v of t of function Q is going to be 1t minus 1.8, 1.25 to the power t. Okay, so when we differentiate this, we're going to get acceleration. So if I want to find the acceleration function of Q, that's going to be the first derivative. And here, since we have a product, we have to apply product rule. So I'm going to differentiate the first term, keep the second term the same, plus the first term, and then differentiate the second term. It is an exponential function, so it just remains the same. But because it's not base e, we have to multiply by ln of 1.25. Okay, so then once we've differentiated, we can now evaluate the acceleration at t equals 1. So when I plug this all in using my calculator, I'm going to end up with 1.25 plus 1 minus 1.8. It's going to be 1.25 to the power 1, and then log of 1.25. And working this out, we get a value of positive, and again that positive is significant, 1.0269. Okay, and this is, I'm assuming this is in meters per second squared. So there's our acceleration. Okay, so it asks, the second part of this asks, is the speed, and that's important, speed, okay, is the speed of the particle increasing or decreasing at t equals 1? Well, if we talked about velocity, we know the velocity is increasing because we have a positive acceleration. However, speed is slightly different. Okay, so speed, we need to know if the actual magnitude of the velocity is actually increasing or decreasing. For that, we need to know if the acceleration is working with the velocity or against the velocity. So we calculated in part B that v of q at t equals 1 is equal to -1. So when we draw out this situation, we have our velocity going in this direction. So we have -1 meters per second. But our acceleration value here is working in this direction here. So it's going to be positive 1 point, it doesn't really matter what this value is, but it's working against the velocity. So I'm traveling with a certain velocity in this direction. I'm accelerating in this direction, which means essentially I'm braking. I'm going against the velocity. So my speed, the actual speed, is decreasing. Okay, so we're going to conclude that that speed is decreasing. And the reason that we can say is that the acceleration is working in opposite direction of the velocity.